Okay, so in this video, I'm going to show you how to create a scatter plot, find its line of best fit, and use that to make predictions about things that may happen in the future. So the first thing I have to point out is if you missed it on the website, please remember you are supposed to read pages 61 through 62 of your book first. So please make sure you've done that so you are familiar with what a scatter plot is, what a line of best fit is, because I will not go into that in this video. So if you haven't, pause the video, read those 2 pages quick first. If they are a fast read, and then go ahead and re-jump into this video. Okay, so we are going to do a specific task in this video. We're going to create a scatter plot from our information here, and we're going to use it to predict the cost for the 2010 and the 2013 Super Bowls. So first thing I have to do is I have to make the scatter plot. So I'm going to have to plot this data. So I'm going to figure out what is my independent and what is my dependent variable. So I can put those on my XY axis. Well, I notice that the cost depends on the year. So I'm going to go ahead and say cost is dependent. So here's going to be my dependent, which means this must be my independent. So when I graph it, I'm going to graph the year on the x-axis and the cost on the y-axis. So this is going to be my x-axis, and this is going to be my y-axis. And the next thing I notice is that when I look at my costs, I don't really want to build a graph that goes all the way up to 2,100,000. So I'm going to notice that this is 2.1 million. This is 1.9 million. This is 2.1 million, 2.2 million, 2.4 million, 2.5 million, and 2.6 million. So as long as I label my axis with the million, I can go ahead and use these numbers instead of these giant numbers. So now I'm ready to go ahead and create my graph. In your notes template, the graph has not been labeled, but you'll notice on mine, I've already labeled some things on it. I'll try to make it a little bigger so it's a little bit easier to read. So what I would first encourage you to do is pause the video and go ahead and add in your y-axis, your cost in millions, and your year axis from 2001 up to 2007. Okay, now that you've got that, the next thing I'm going to do is now I'm going to plot some points. So the first point I see is in 2001 I was at 2.1. So I'm going to go ahead and say in 2001 I'm going to go to 2.1, so halfway between 2.0 and 2.2, and I'm going to plot my first point. I'm going to go ahead and pause my video to plot all my points. I would encourage you to follow along, go ahead and plot all your points, and then make sure your points match up with mine. Alright, I now have all my data plotted, so again I would encourage you to do the same. Make sure that your data matches mine. And now I can see it looks like there's a positive correlation. So I did have a little bit of a dip in 2002, but other than that it looks to be a positive correlation. So now I want to go ahead and draw in my trend line. So remember, my trend line is going to be as middlemost as possible. I may go through points or I may not. So I'm going to go ahead and I'm going to grab a line. I should use a ruler, but with the iPad that I use to record these videos, it doesn't allow me to lie a ruler down on it and recognize one touch point. So I'm not going to use a ruler, but know that you would be more successful with a ruler, so I would expect you to use a ruler. And I'm going to try to be as middlemost as possible. And I may not get it in my first shot, so I may have to redo it. But I'm going to go ahead and I'm going to say that I maybe look something like this. And I maybe could bring it down just a little bit. So I'm going to try once more. Maybe not. Maybe it won't let me. All right, I guess I'm going to leave it as is. Again, I could be maybe just a little bit lower, but I am somewhat middle. I have 3 above the line. I have 4 below the line. So now I'm ready to go ahead and create an equation for my line of best fit. Well, think back to our previous objective. I need 2 things to write an equation. I need a point and a slope. Well, I could find the slope of this line because it looks like it passes through quite a bit of points. So I'm going to find 2 points on my line. They may or may not come from my data set. I'm going to say that again. I'm going to find 2 points on my line, and they may or may not come from my data set. So let's see, looking at my line, I'm going to go ahead and say this seems to be like a nice point right here. And looking for another nice point. I'm going to go ahead and say, actually this seems to be a really nice point here. I'm going to name those 2 points. Notice that neither of them came from my data set. That's okay. So I'm going to say I have the point 0, 1.4, and I have the point, looks like 2002.5, which is kind of weird. And actually, I'm not going to use the point 0, 1.4. The reason is because I started my graph at 2001. I didn't take into account all the numbers, all the years before 2001. So this is going to be a little off, this piece of my graph here. So I'm going to use that point, and I'm going to use this point instead. Excuse me. And let's see, then that's 2.0 for the cost. And let's see, this point up here is 2007 and 2.8. All right, and now that I have 2 points, I'm ready to go through my process that I learned in my previous objective. So I'm starting with my steps. My step 1 is to find the slope. So I'm going to say m equals y1 minus y2. I'm going to go ahead and say this is my x1, y1, and my x2, y2. So I'm going to say 2.8 minus 2.0 all over 2007 minus 2002.5. Now, most of the time I want you guys to not work with the calculator and to use fractions. Scatter plots is going to be the exception to that rule. You can go ahead and use a calculator with a scatter plot. Another thing to know with scatter plots, because we're all going to have different graphs, we're never going to be exactly the same, but we should be close. So I get a 0.8 on top and a 4.5 on the bottom. And doing top divided by bottom, I get about 0.18 for my slope. Now, I would prefer, rather than you try to mimic exactly what I'm doing, I would prefer you to use your line of best fit, which may have different numbers than mine. So you'd be using the same process, just possibly different numbers. And my line, as I said before, was a little high. I could have went a little bit lower. So I may have a higher slope than what you do if your graph was a little bit, or your line was a little more accurate than mine. Now that I know the slope, I can go ahead and say y minus my y1 equals my m times x minus my x1. And I'm going to go ahead then distribute. I'm going to get y minus 2, because I don't need the 0.0, equals 0.18 times x minus 360.45. Scroll down a bit here. And now I'm going to add, oh, excuse me, I distributed. I don't need those parentheses anymore. So I don't think it's going to let me erase because I moved the screen. So I'm just going to rewrite that. So I have y minus 2 equals 0.18x minus 360.45. And then I'm going to go ahead and add 2. And I get in a final equation of, so finding the cost in 2010. So here's my equation after I added the 2. And finding the cost in 2010. Remember, 2010 is my x value. The year is my x value. So I plug 2010 in for the x in my equation. And now I just put this into my calculator. So 0.18 times 2010 minus 358.45 gives me $3.35 million. So a pretty expensive commercial. And then again, predicting, the other one I was supposed to predict was the 2013 cost. And I'm out of room on my page. Let's see if I can just move everything up a little bit. So then in 2013, again, the year is my independent, my x value, so I plug that into my equation I found. And again, I can use my calculator, 0.18 times 2013 minus 358.45, and I get $3.89 million. So how accurate are we? Well, go ahead and use Google to see how much last year's Super Bowl, or the 2013 Super Bowl commercial cost. So that'd be a great thing for you to check out. And then also, if you could bring this with you to class, and we can use this when you're working on your practice or your project with scatter plots.